A cathode ray tube beam deflects to the location as shown in diagram 1 when a certain voltage is applied to the deflecting plates. The connections to the deflecting plates are then reversed and the deflecting voltage is reduced. Which location in diagram 2 best represents the new beam position? So a couple things to note here. It may be useful to remember sort of the structure of a cathode ray tube. Basically we have from the side, let's say we have our accelerating plates, and then we usually have vertical deflecting plates and horizontal deflecting plates. So the horizontal deflecting plates are going to be kind of hard to portray from the side view, so how about we just forget about them for now, since we can see that this deflection is just vertical anyways. So for our purposes, this is all we're concerned with. So we're going to be accelerating a beam of electrons, and then they're going to be deflected by these vertical plates. So if this plate is positive and this plate is negative, the electrons will be deflected upwards. However, if we reverse the polarity, so we make this plate positive and this plate negative, the electrons will be deflected downwards. So we see in the diagram, in the first case, it looks like the upper plate in the vertical deflection set of plates must be the positive plate, since we see that the deflection occurs in the upwards direction. But then when we reverse the polarity, the electrons are going to be deflected in the opposite direction. So that means that the bottom plate will be positive and the top plate will be negative, causing the electrons to be deflected downwards, kind of like how I've drawn here. So that tells us that the correct choice is going to be either option 3 or option 4, since we know that the electrons will be deflected downwards since the polarity of the deflecting plates is reversed. Now we just need to figure out if the deflection will be greater or less than it was in the first case. So to figure out which of these two locations is going to be, location 3 or 4, we need to remember that the deflection is proportional to the deflecting voltage over the accelerating voltage. So the key takeaway from this proportionality statement for this problem is that the deflection is proportional to the deflecting voltage. We're told by the question text that the deflecting voltage is reduced. So that means that the deflection will therefore also be reduced, since the deflecting voltage and the deflection are directly proportional. So that means that option 3 is going to be the correct choice, since it shows deflection in the opposite direction from diagram 1 and also slightly less deflection than in diagram 1. So you see that this deflection here is less than this deflection here. Okay, so that's why the correct choice here is location 3.